So what you can write? Log K2 by K1 whole power 1 by K2 minus K1. Already here K1 is there. Correct? So I am writing this equation as B max equal to K1 A naught upon K2 minus K1 into e power K1 into this term. Log K2 by K1 whole power minus K1 upon K2 minus K1. Response, sir. Correct? Minus e power log K2 by K1 power minus K2 upon K2 minus K1. Response, sir. What happens to e power log term? Or e power log x? X. So B max equal to K1 A naught upon K2 minus K1 into K2 upon K1 can write as K1 upon K1 minus K2 negative term minus K2 upon K1 K2 upon K1 minus K2. Response, sir? Is there anything wrong? Is there anything common can I take further? Listen. Listen. I am multiplying and dividing with K2 by K1. I am multiplying and dividing with K2 by K1. So I am multiplying with K2 by K1, dividing with K2 by K1. Response, sir. If I divide with K2 by K1, power becomes minus 1. Na? Respond. So then what is this equation? P max equal to K1 A naught upon K2 minus K1, K2 by K1 whole power, K1 upon K1 minus K2 minus K2 upon K1. This becomes K2 by K1 whole power. Take LCM. K2 minus K1 plus K2. K2, K2 gone. So what is left? What is left? Minus K1 upon minus K1 upon K1 minus K2. What, sir? I am not able to take it common now. Okay. Why? Oh, it is becoming 2 times, huh? Then do one thing. Do one thing then. Wait. I need to make these two coefficients equal, sir. How I can make these two coefficients equal? Instead of doing that here, instead of doing here, do the same thing here. Instead of doing for this term, I am doing the same thing here. Now what is this equation? K2 by K1 I am keeping aside into K2 by K1 power K1 minus K1 plus K2. K1, K1 gone. So what is left? K2 by K1 minus K2 minus K2 upon K1, K2 upon K1 minus K2. Now can I take something common? Now what is left? K1 A0 upon K2 minus K1 into K2 upon K1 whole power. K2 upon K1 minus K2 is taken common into what is left? K2 by K1 minus 1. What is it? LCM. K2 minus K1 upon K1. Correct? Now, can I cancel this? So what is B max? B max equal to A naught into K2 upon K1 whole power K2 upon K1 minus K2 over. Right? B max, B max. Both are. So we are done with sequential or consecutive reactions. Right? Now, once you open your target booklet, in page number 13, we have parallel reactions, right? Then we need to discuss something from page number 16, right? So instead of that, what we have done is go to page number 58. Page number 58. Additional information. What is it? Consecutive first order reaction. Correct? A gives rise to form B, B gives rise to form C. Correct? Same graphs or not? Observe the graphs, sir. What they give? In the first graph, concentration of B is more. Correct? In second graph, concentration of B just appeared and decreased. Same graphs we have seen. Right? Now, where are equations, man? See, they have not given anything. Okay, they have not given anything, man. They simply gave those two graphs, right? From that graph, they may frame question. Right? See the first graph, right? From the first graph, at what time concentration of B may become maximum? Means this is only now we have to do T max, B max. So that can be derived from the graph given in page number 59. Here, they gave dB by dt derivation also. In page number 59, at the middle of page, see what they give. Mathematically, the latter can be written as dB by dt equal to 0. What do you mean by dB by dt 0? Maximum concentration. Instead of deriving it, they simply gave the equation. dB by dt equal to 0 means what we can write? K1A minus K2B equal to 0. So B equal to K1 by K2A. Correct? That's what, K2 by K1 into A. Condition math. Here also see this. Here also, what we can write is, if K1 is far greater than K2, if K1 is far greater than K2, then what happens? K1 can change. B forms more. From B, formation of C will be less. Means concentration of B becomes maximum. If K1 is far greater than K2, what happens to the power? So K2 by K1 power K2 by K1. Right? K1 is higher, na? Denominator is high means what about K2 by K1 value? Approaches 0. Right? Correct or not? Means the total term approaches. Means nothing but approaches to A naught. Are you able to understand? Concentration of B maximum can approach up to A naught. That is the meaning of it. Correct only, na? And initially I have taken A. If a formation of B speed is more than formation of B to C, what is the maximum possibility of B? A naught. That only we prove. Clear? They gave this question also. Huh? I need to discuss one more point here. In this book, what they have given is they simply gave one graph and they left. But in JE Advanced, one small idea is enough to prepare questions. Okay. Now see this. This is about sequential reactions or consecutive reactions. Now we are going to see the third type of reaction, sir. We are discussing complex reactions in which first one is parallel. Second one, sequential or consecutive. In that we found concentration of A after time t, B after time t, C after time t. What is the maximum concentration of B? What is the time where B becomes maximum? One is called secular equilibrium, another is called transient equilibrium. Transient means transition, transient. It will form and decompose. Means which is transient among these two? First one. B formed and vanished. So transient equilibrium. B became maximum. Means at all times you will find some amount of A, some amount of B, some amount of C. Secularism. Secular equilibrium. Are you able to understand? So secular equilibrium, transient equilibrium. Clear? Now I am taking one more reaction, sir. Opposing reactions. Already in chemical equilibrium, we discussed that every opposing reaction reaches equilibrium after some time. Right? Now, if they ask you what is the kinetics of it, there we are simply writing K equilibrium equal to concentration of C into D by A into B. Now we need to prove it. Right? For example, A gives rise to form B, B gives rise to form A, are opposing reactions. Let me assume forward kinetics K1, backward kinetics K minus 1. Right? At time t equal to 0, let the initial concentration of A is A, B is 0. After a certain time, it becomes A minus X, X. When time t equal to T equilibrium, A minus XE, XE. Correct? What is XE? Concentration of B after reaching. Right? Every opposing reaction finally reaches equilibrium. So, yes, madam. Yes, madam. Yes, madam. Yes, madam. Yes, madam. How are you? Good, madam. Right. So we know that every opposing reaction reaches equilibrium after certain time, right? Even when time t equal to infinite, its concentrations remain same. Then only we call it as equilibrium reactions. So here it is reaching equilibrium. Here it is opposing. Correct, sir? At this position, it is opposing. Right? How to write rate expression for it? Can I write dx by dt, or when time t equal to t, change in concentration of A is x. So I can write it as dx by dt, or I will write as dv by dt. dv by dt also dx by dt only, na? Response, sir. Final concentration minus initial concentration by t. What is that? X. Here also final concentration minus initial concentration by t. Minus x, but it is reactant, so I will write minus dA by dt, na? Response, sir. Minus dA by dt is nothing but equal to rate. Is nothing but equal to dB by dt. Correct? dB by dt, I am writing it as dx by dt. Here what I will write? Change in concentration of A. A minus x minus A becomes minus x. Minus or minus again. Plus. So again it becomes equal to. So rate is directly written as, therefore we can write rate as dx by dt. Correct? Equal to what you will write? What is dx by dt equal to? X value is decreasing. I'm writing it as dB by dt equal to, what I will write, dB by dt equal to. P is forming with one speed, decomposing with some speed. So what is formation speed? K1 into AT minus K minus 1 into BT. Correct? Correct or not? This can be written as dx by dt only, na? Not, sir. So I'm writing dx by dt as K1 into AT minus K minus 1 into BT. Done? Right? Now, dx by dt equal to K1 into AT can be written as A minus X. BT can be written as X. Right? Any questions in it? At equilibrium means when time t equal to t equilibrium, x becomes equal to x equilibrium. Then what is dxe by dt equal to? Reason? It remains equal. It reaches equilibrium means concentrations remain constant. Correct? So dxe by dt equal to 0 means, then what happens to this equation? A1 into A minus xe becomes equal to K minus 1 into xe. Acceptable?
Yes, sir.
Hmm? Right. From here, I'm expanding it. K1A minus K1 into xe is equal to K minus 1 into xe. Correct, sir? Bring xe terms to the one side. K1A equal to K1 plus K minus 1 into xe. Response, sir. Means K1 plus K minus 1 can be written as K1A upon xe. This is one form of equation. Or xe can be written as K1A upon K1 plus K minus 1. This is another form of equation. Any questions in it? No. Coming to this equation. This is at equilibrium. This is at time t equal to t. We are studying about what reactions? Opposing reactions. We are not studying about equilibrium reactions. No? We are studying about opposing reactions. Means when time t equal to t only, not equilibrium. Correct? Now, I am writing this as dx upon dt equal to K1A minus K1x minus K minus 1x. Dx upon dt equal to K1A minus of K1 plus K minus 1 into x. Correct, sir? Can I substitute K1 plus K minus 1 value? So what is this equation now? Dx upon dt equal to K1A minus K1A into x upon xe. Can I take LCM? Dx upon dt equal to what we can write? K1A into xe minus x upon xe. Response, sir. Any questions in it? Now, dx upon xe minus x equal to K1A upon xe into dt. Acceptable? Integrate on both sides. Integrate on both sides. What is integral of this value? Correct? Huh? Xc minus x. Differentiation of this minus. Right? Between the limits 0 to x. When time changes from 0 to t. So here I am applying limits 0 to x is equal to k1a upon xe 0 to t. Correct, sir? What happens to this term? Substitute x and substitute 0. What do you get? Minus log xe minus x. Or I will write this negative sign outside. This minus log xe minus 0. Then this term becomes negative and that xe term becomes positive. So what do you get? Log xe upon xe minus x. Acceptable? Correct? Is equal to k1 at upon xe. Means k1 equal to rate constant k1 equal to what will get? Xe upon at log xe upon xe minus x. Rate constant for opposing reactions. Now, instead of xe also can I substitute this term? Means if I substitute that term, what will you get? Substitute that xe term here. What will you get? K1 equal to, instead of xe, I am writing K1a upon K1 plus K minus 1 into at log xe upon xe minus x. K1, K1 gone. A gone. So what is the equation? K1 plus K minus 1 equal to, what do you got? 1 upon T log xe upon xe minus x. This is another form of equation. Response, sir. Possible? No. One more. Try to bring any equation in terms of k minus 1. Bring any equation in terms of k minus 1. I want equation only in terms of k minus 1. We got equation in terms of k1 and k1 plus k minus 1. I want equation in terms of k minus 1. What you can do? Subtract both. Subtract. What do you get? Subtract. Observe this. From here, sir. Observe this equation, sir. From here, can I take k1 common? Can I take k1 common? So what is the equation? K1 into a minus xe upon xe equal to k minus 1. Possible or not? Say something. K minus 1 equal to k1 into a minus xe upon xe. Correct? Now you know k1 equation, right? Substitute this k1 equation here. What do you get? K minus 1 equal to a minus xe upon xe into, instead of k1, xe upon at ln xe upon xe minus x. Acceptable? Correct? Xe gone. So what is the equation? K minus 1 equal to a minus xe upon a into t ln xe upon Xe minus X. This is third equation. So as such, we can write rate constant equation for opposing reactions in 3 ways. Right? What is K1 upon K minus 1? What do you mean by K1 upon K minus 1? Equilibrium, na? K forward by K backward. So what do you got? Xe upon A minus Xe. Correct or not? Xe upon K minus Xe. Correct only, na? Response, sir. This we have studied already in equilibrium. But we want to show what is K forward equation, what is K backward equation, what is K forward plus K backward equation. In equilibrium, we studied K forward upon K backward. Here we are studying what is K forward, what is K backward, what is K forward plus K backward. Clear? Response, sir. So kinetics for equilibrium reactions, or we call it as opposing reactions following first order kinetics. All are done. Clear? Okay, wow. I think last year's JEE advanced question, they framed this question based upon opposing reactions. Now, come back. So in previous class, we have seen experimental methods of determining rate constant. After that, we have seen, according to our syllabus. After that, what we have seen? Parallel reactions or sequential reactions. Sorry, parallel reactions are simultaneous reactions. Sequential opposing are extra concepts, right? Then what we have seen? We need to see factors affecting rate of a chemical reaction. The topic we need to see. So next slide headings are factors affecting rate of a reaction. This we will discuss in next class. Right? If they want to frame tough questions from chemical kinetics chapter, definitely they will frame questions from parallel, opposing, sequential reaction. The remaining all other questions are easy only, na? First order kinetics, nth order kinetics, half-life, all those equations are common, right? Derivations also I already given. Just once go through that, that is enough, right? Right, sir, I will end the session. Online students, are you following or not? And many students has not given yesterday's test, sir. Those who have not given test yesterday need to give the test offline on coming Saturday or Sunday. Which you prefer? Sunday? Sunday daytime. What, sir? I told you many times. If you start skipping the test, better take a drop now itself. Whether you prepared or not. First mandatory condition is you should not skip any test. Right? In weekdays on Wednesday, for example, you have school homework, something is there. At least come and give the test on Saturday evening. Saturday evening, 5:30 to 8:30, you can come and sit and complete the test, no? Or Sunday morning, you can come and complete the test. What you will prefer? Saturday evening, right? Those who are not given the test, sir, give the test on this Saturday, means tomorrow. 5:30 to 8:30, come and give the test offline. Right? I will ask EDP to print the paper, give the test, submit the OMRs. We'll make them to run that. Okay? Right, sir. I will end the session.